Hey guys, today we're going to be finding solutions to a little bit longer of equations. The last video you watched was called one-step equations because you only had to move one number away from the variable. Today we're going to have two steps to move. So here's how since we're going to have two numbers to move, we have to be careful in figuring out which number to move first. The first thing we need to do is make sure we keep the variable in the same spot. That's kind of the key to everything here. We're going to keep the variable in the same spot and move all the numbers or all the other values away from it. We're going to do that by following reverse PEMDAS, and that's going to actually tell us what to move first. So when we follow reverse PEMDAS, the first thing we look is whatever is being added or subtracted outside parentheses first. Because again, remember, PEMDAS is the order of operations. Reverse PEMDAS means you start in the back. You look for whatever is added or subtracted first. You have to remember it has to be outside of parentheses. If it's inside of parentheses, well, that will actually be the last thing we move in reverse PEMDAS. So after we move what's added or subtracted outside of parentheses, we're going to move what is multiplied or divided, because we can see how after addition and subtraction, if we go in reverse, we are going to do multiplication and division. And then the last part will be move what is in parentheses. Now I did skip over exponents here. If there was an exponent, we would have to eliminate that, but you typically will not see that in 7th and 8th grade. So, okay. Let's take a look at one. We got a few examples we'll cover. Let's start with this one. Okay, so I'm gonna do this. My first step kind of the same as we're used to from the previous video. I'm going to draw a vertical line to represent the equal sign. That helps me remember what I do to one side, I do to the other. And then let's look. So I know that I'm following reverse PEMDAS. That means I'm going to move what's added or subtracted first outside of U. And I'm focusing on the variable. So what is being added or subtracted to the variable? Well, I see how we have minus 2. So I can do the opposite by adding 2. Whatever I have to do to one side, I have to do to the other. As we learned in the last video, these cancel out because they equal to 0. Now we're left with 2r equals, and then here 8 plus 2 does not cancel out. 8 plus 2 will equal 10. Okay? So we took care of what was added or subtracted. Next we look for what is multiplied or divided. Here I see 2r, no symbol in between. That means 2 times r. So the opposite of times or multiply is divide. So I'll put my division bar. As we saw in the last video, these cancel out. So we're just left with r on this side. 10 divided by 2 over here will give us 5. So r will equal 5. And you can always still check this by simply substituting the solution you found into the original equation. So I could just write this as 2 parentheses 5 now, because that's the solution I found. Two times 5 gives me 10. 10 minus 2 gives me 8. There we go. So we would say this is true. 8 equals 8. So r equals 5 is a solution. Okay. So that one was simple enough. Let's check out one that might be a little more difficult. I picked the types of problems I figured would give us the most trouble if we were trying it on our own. That way you can see how it's done first before you try it on your own. So this one always kind of mixes people up, I think just because of a fraction bar. Let's go ahead and get into it. So I'm going to draw that vertical line underneath, and I'm going to follow reverse PEMDAS. So I'm going to move what's being added or subtracted first. So here's t. We see how negative 11 is being added to it. So we're just going to subtract negative 11. Now you could have put subtract negative 11. You could have put adding the opposite. I chose to do it that way. So we're subtracting negative 11. These will cancel out. You can test it in the calculator. Do negative 11 minus negative 11. You'll see how it equals 0. And we'll be left with t over negative 3 equals, let's see, negative 12 minus negative 11 will give us negative 1. Okay, we're down to this. And now just remember, this fraction bar, that just means division. So we have to do the opposite of dividing by negative 3. That's going to be multiplying by negative 3. What I do to one side, I do to the other. As we saw in the previous video, these cancel out. We're just left with t. So we have negative 1 times negative 3 on this side. That'll be positive 3. Not sure why I put a negative sign. So there we go. T equals positive 3. And of course you could check that. I won't do so because I want to keep this video a little bit shorter. You could easily check that using your calculator though, or on paper. All right, example 3. This will be our final example for this. So example 3, don't be afraid of the decimals, don't be afraid of the parentheses. First things first, I'm going to draw my vertical line under the equal sign. Then I look, and I remember I have to do reverse PEMDAS. Just be careful though, because, let me scroll back up to it, we have to move what's added or subtracted outside of the parentheses first. So even though we have minus 13 inside parentheses, we're not going to do that first because that wouldn't be following reverse PEMDAS. So there is actually nothing being added or subtracted outside of parentheses on the same side of the equal sign. So we'll skip over that. Now I do see how we're multiplying this set of parentheses by negative 3.35 because there's no symbol here. So we're going to have to divide by negative 3.35. And we'll do that on both sides. So over here, that will give us, well, these will cancel out. We'll be left with z minus 13. So here, I don't really need the parentheses anymore because everything that was outside of parentheses got canceled out. So I don't need those anymore. Over here, doing this division, negative 13.4 divided by negative 3.35 gives me positive 4. And now all I have to do is move my minus 13. This is a one-step problem. So I will add, which is doing the opposite, 13 to both sides. So we will have z equals 17. There we have it, guys. Kept that under 10 minutes.